Let's continue. Now let's take a look at this. This is a typical example of the second questions of my part, where you have to design the whole thing. Now, so you are given this circuit, and the first question is plug. How come I can't hear you? I thought everyone already. Okay, can you please mute yourself? Okay, so the question is you have to apply KCL to derive the V plus. So this is quite a simple case because we have seen this kind of circuit many times since your year one. When you analyze the op-amp, very important point is the voltage at the two terminals are the same, and there is no currents run into the op-amp. So you can think of, you don't have this wire, right? So imagine you have one current here, I call I1, another current I2, another current I3. Right? So someone has a question? So if you apply KCL, I1 plus I2 plus I3 should be 0 because they are all entering, right?
Sir, where
what
is your
is
sir? Where is your screen? Your screen is question 1.
I mean my screen is just frozen?
I think there's a lag. It's okay now. It's okay now.
Okay, wait. So now I am in the question 2, right? And can you see your question 2?
Yes, sir.
Okay. So the three current, they are all entering the V plus. So the sum of the three must be 0. But what is I1? Anyone can tell me what is I1? Ohm law. How to have the formula for I1, which is Ohm law? Is V1 minus V plus divided by R. I2, same thing, V2 minus V plus divided by R. And V3 minus V plus divided by R. This one all 0. So basically, they are all divided by by R, right? So you can forget about this, or you can think of, I multiply this one with R, this one multiply with R, the right hand side still 0, right? And on the left hand side, I can cancel all the R. So that is one way to look at it. So at the end, what you have is V1 minus V plus V2 minus V plus V3 minus V plus. This one is 0. Then this one should be V1 plus V2 plus V3 minus 3V plus should be 0. right? Or 3v plus is v1 plus v2 plus v3, or v plus is v1 plus v2 plus v3 divided by 3, right? Okay, any questions? Now, this is A, right? Oops, this is A. Okay, what happened to my this question A? I don't understand how. Question B. What is the formula of B minus, right? For B, okay. B minus, which is the inverting terminal of the op-amp, should be the same as B plus. So this one, what you have is V1 plus V2 plus V3 divided by 3. Right? And they ask, from there, you derive the output voltage, Vout. So what they ask is what it is, right? What it is Vout. So the way to have the formula for Vout is quite simple, because we have done this one quite a lot of times, to be honest, since your year one, and also in the course we also redo it. When you analyze the op-amp circuit, you just apply the KCL and Ohm law. That's it. No need to apply KVL. Now, you look here, you will see the current running here. The current running here. Here is a ground, so this one should be V minus. Right, so I call this is a current I 4, and imagine this one is a current I5. So the current I4, very simple, is V minus divided by 1 kilo ohm. And the current I5, Ohm law, right, tell me this is V minus minus V out divided by 2K. And because I1 leaving, I5 also leaving, so I4 plus I5 should be 0, right? And because here everything is is kilo ohm, so easily I can have, just forget kilo ohm, right? So here I have V minus divided by 1, which is V minus. And here on the I5, I can have V minus minus V out divided by 2 equal to 0. Now, you can think of V minus as V minus divided by 1. So this guy must multiply by 2. This guy must multiply by 2. Correct? So after you multiply by 2, what should you have? You have 2 V minus, right? Plus V minus, right? Minus V out, right? And divide by 2 is 0, right? So from here, you have V 3V minus V out is 0, or V out is 3V minus. So if you have 3V minus, basically you have V1 plus V2 plus V3. So this question is quite easy, to be honest, because we done the analysis in our lecture, and now they ask you to redo the analysis. We look here, this is something similar to the non-inverting amplifier. Now the question C and the question D is similar to the thing we have done in our tutorial, also quite similar to the quiz, because it is about the filter here, right? And pass filters. So what they want is they want the pass band to be 1 kilohertz to 10 kilohertz, and they want to get the gain of 40 dB. Gain of 40 dB. So a few things. This is a few things we have seen in our class. So if you can think of the pass band is like this. So you have here, for example, like this. So this is a max, right? This is a max gain. And if you go down to 3 dB, so this one is like 40 dB. This one is again in dB, 40 dB, then this one should be the point of 3 dB down. So it should be 37. And at this 37 dB gain, you have two cutoff frequency. This F1 should be 1 kilohertz, and this F2 should be 10 kilohertz. Now we know that our bandpass filter will be built by using a low pass filter or a high pass filter. Or if you want, you can have the high pass filter first, and then you can have a low pass filter. It doesn't matter. So anyone can tell me for this cutoff frequency of 1 kilohertz, this cutoff frequency belongs to which filter?
High pass.
This one belongs to the high pass.
1
Right.
kilohertz.
Yeah, high pass. And for the low pass filter, the cutoff frequency should be higher. Okay. So I hope you still remember when we talk about this. I show you what happens if you have a low pass filter. The cutoff frequency is 1 kilohertz, and the high pass filter, the cutoff frequency is 10 kilohertz. So basically, you remove all the frequencies. So the cutoff frequency of high pass filter must be lower than the cutoff frequency of the low pass filter. So that is point number one. So basically, when you have this, right, you already can determine what is what is a formula for the cutoff frequency. The cutoff frequency is 1/2 pi RC, right? Correct. So you can
Yes.
so from here, right, you know what is a product of RC for this high pass, what is the product of RC for this low pass. And the question is open-ended. It's something like design. So you can choose. You can choose the values. Another thing is again, the gain is 40 dB. So the gain in dB is 40. But how to calculate the gain in dB? The gain in dB is 20, right? Log base 10 of the normal gain. So from here, you will see the log base 10 of G, the normal gain, 40 divided by 20 is 2. In other words, G, the normal gain is 10 to the power 2. All right. So you see, I can have different way. For example, I can have the gain of this guy is 100, and the gain of this one is 1, right? So for example, this one is the gain is 100, this gain is 1. The total gain is still 100, right? So this one is 100. It's also gain, or you can design in such a way that this have the gain of 10, this has a gain of 10, then the total gain is G1 times G2, right? It is also 100. Or you can use different combination, right? So it is because the question is about design, so it's very open-ended. There's no fixed solution, right? When we mark this kind of questions, we mark based on what you do and to show your understanding. We the solution just suggests the solution only, right? Okay. So now, can anyone tell me where should I find the circuit? Which topics? Show you here. Of course, if you want to have a gain of 40 dB, you must use op-amp. Right. So let me show you. No, I still remember this. Correct. Right. So imagine that if you are to suppose you use this one as a this one is a low pass, right? This one is a low pass. This one is a high pass. And imagine if you design the gain to be 10 and 10, then the ratio of this should be 9, right? Agree? Because this one is a gain, this one is a gain. So it should be 1 plus 9, it should be 10. So not this one. Where is the file? So you can design the this one first, right? And something like this, right? So this one, right? This one should be 9R, for example. This one should 9R0. This one should be only R0. So this you will have a gain of 10. Right? So you can choose, for example, this one you have 90K. This one you have 10K. So basically you have a gain of 10. Then for this one, you have another. So this one is you understand my out here, right? And this one is V0. For example, 90K. This one is 10K. This one is Y. This one is R1. This one is C1. This one is R2. This one is C2. So you have to choose in such a way the 2 pi R1 C1 should be. This one is a low pass, right? It is a 10 kilohertz. And you have to choose the R2 C2 in such a way. This one is 1 kilohertz. Now, if they say there's a frequency of 5 kilohertz, amplitude 10 millivolt, what is the frequency and what is the amplitude? The output of the filter. So you can think of this. Now, the pass band is from 1 to 10. So the signal you have is 5. 5 is somewhere here. So it's in the pass band. So the frequency as the output must be 5 kilohertz, right? Correct. And what is the voltage as the output? Now, it's gain times the voltage in, right? So your gain is 100 and your V in is 10 millivolt. So this one is 1000 millivolt. If you want to convert in dBm, so in dBm, anyone tell me what is the formula? So
20 log V output over V input.
yes. 20 log of the V output in millivolt. So this one, so this one is 60 dBm. So you will see for this paper is it's not difficult. Now, this is another one. Now you will see
So
these
can show previous
questions.
page again. Okay, thank you.
Anyway, this I will upload this file for you. So I need to now just try to work along. Now, this one is exactly the same kinds of tutorial questions, right? Okay, 7 mark. Don't understand what happened to my writing pad. Small. Okay. Now, for the question A, let me write it down. So to visualize, you can think of this as IDC. digital to analog. So this one must be digital input, right? And here, what do you have? You have current out. And this one it has. Now they say the max output. So when you have max output, you have max output when you have max input. So max input should be 1 1 1 1, like 1 1, like 1 1 1, 1 1 1. Sorry, 1 1 1 1 in binary. Now this is 10-bit. So I already show you how to use calculator to convert, right? This one should be
1023.
yeah 1023 in decimal. So from here you can easily see K should be 24 milliampere divided by 1023. And your input 10111011. Now, can you help me to determine what the values of this in decimal?
747.
747 in decimal. So the I out should be 24 milliampere over 1 here. 747, which is, can you help me?
$17.52. 17.52.
Yeah, 17. So it's quite easy. So again, the question B is actually similar to what we have done in our tutorial. It's just like different way to phrase the question slowly. So let's look at this. You can't hear me? Can you hear me?
Cannot, sir.
Can hear.
Cannot. Very late.
Okay. Why? Is it okay now? Okay. Now, so let's take a look. Now cannot hear. Can you hear it now? Cannot hear at all? Anyone? Can you
Yeah,
hear
can,
me?
sir. Can.
Okay, so for B, I, This one is temperature sensor. So to visualize, right? To visualize, this one is your sensor. To make it easy to understand, this one is sensor. The input is from minus 50 degrees Celsius to 125 degrees Celsius. And when your input is minus 50 degrees Celsius, output is 0 volt, right? So it's something like this, right? 0 volt. And when you are at 125 degrees Celsius, output is 1.75 volt, something like this. So they ask you to sketch the output and they test you the concept of sensitivity. Now, take note, sensitivity is nothing but just a slope, right? Or the tangent, right? So the way you draw is here is the output, which is a V, and here is the input, which is T, right? The unit is degrees Celsius, and for V, the voltage is the unit is volt, right? And for here, you have here is for minus 50, this one 125, and at this point you have 1.75. So this is a point, and this is a point, correct? 0. So this is the input-output relationship, and sensitivity. Now, in terms of millivolt per degree Celsius. So you look, you go up from 0 to 1.75. This is a change in the voltage. And what is a change in the temperature? Minus 50. This one you have 1.75 divided by 175. So this one is, then they ask for millivolt, right? So 100. So is it 1 millivolt per degree Celsius, right? Because this one is volt.
So
Oh, no,
should be
10.
10.
Should be 10.
10.
10. Because you multiply with 1,000, you should have 1750. Right, so it's 10 millivolt per degree Celsius. Now you will see the question number 2 is very much similar to this. Like this. Right? It's very much similar. The very first one. So is to be honest, it's not difficult. It's really not difficult at all. So for the question 2, right? So for visualizing, you have all the way from minus. But this one, when I write for you, I try to do some explanation. So when you write in your paper, in your answer booklet, you don't need to write too much like what I'm trying to write here, because I'm trying to explain for you. So this one you can think of, you have minus 50 degrees Celsius to 125, and this one now is mapped to 0 to 1.75, right? And now the ADC input is 0 to 5, right? 0 to 5. And because this one is 10 bit, right? So you have many steps here, right? So how many steps? So number of steps. is 2 to the power n minus 1, which is 2 to the 10 minus 1. Just now we use 1023. So here is 10 bit, here also 10 bit. So I save you some calculation actually, right? So you must remember the number of steps here is from 0 to 5. So the number of steps from 0 to 1.75 should be 1.75 divided by 5 times 1023, right? Which is, can anyone help me? What is the value?
358.05.
3,
58.
5, 8 point.
05.
Okay,
05.
so approximate, right? Because we just need to take the whole number. So from here, very easy, you can have resolution. Now the whole range is 175 degrees Celsius. Because you have the range from -50 to 120, so the range is 175. And this one will be covered by 358 steps. And remember, by step, I means if you move right from one end to the next end of the step, basically the output is changed by 1. So this one, can you help me?
Uh, 0.49.
0.49, right? Degrees Celsius over 1 step. You see this quite simple. Now, what is the problem with this? The problem with this, this one you can have your own words, right? You can answer in your own voice. So a few things you can mention here, right? The output, the V out of sensor. Why is like this? By lower. V
So
out of
question.
Yes.
Just now for part 2, right? The question asks us to map to 0 to 5 volts, right? But you are doing the 0 to 1.75 first.
Because the thing you measure is in temperature, right? Degrees Celsius, and the sensor will provide a voltage, right? So
Yeah,
so
we are
this
calculating the resolution for 0 to 1.75, which takes up 358 steps, right? So the question wants what? The configuration from 0 to 5 volts now, right? Not 0 to 1.75.
oh let me draw here. This one is a sensor. Then link to the ADC, right? ADC requires 0 to 5, right? And this one is 10 bit. Therefore, from 0 to 5, we have 1, 0, 2, 3 steps, right? Agree?
Yeah.
This is the minus 50 degree to 125 degree, and the voltage here you have is only 0 to 1.75, right? So this one is only a portion of the range you can use from 0 to 5, right?
Oh, okay, get it.
Ah.
Thanks.
So for example, BR sensors is from 0 to 1.75 volt, which is not fully cover the range of ADC inputs, right? Because of this, then we don't fully use or fully use 1, 2, 3 steps of the ADC, right? So from here, we'll see we have resolution of 2.49 degrees Celsius per step, right? But if we fully use, right? If we fully use 1, 0, 2, 3 steps, the resolution will be 175 over 1023, which is 0.171 degrees Celsius per step, right? Which is better than 0.49 degrees Celsius per step. Okay, so you can use your own words, because this one we also mentioned, right? We already mentioned in the tutorial as well. Then the circuit to achieve the best possible resolution is use an amplifier with gain of pi over 1.75, right? Right? It's about 2.86, right? And what you can do is you can use a so this one is your V out from the sensor. This one should be V out of the sensor. Correct. And here you have the ground, the feedback. This is an inverting amplifier. Right. So this V will be linked to the ADC, right? So this one is R1, this one is R2. And the gain is 1 plus R2 over R1, right? And this one should be 2.86. So from here, R2 over R1 should be 1.86. Right? So you can choose like R1 is 10K, then R2 must be like 18.6K. So basically, this is actually is a questions in our tutorial. Remember? It's the same like the question in our tutorial. But just change values here and there to see whether you remember or not. Okay, so this is the questions about the bridge. So this one is very simple already, right? Can you tell me what should be the values of R? So we have here fix, but this one can be changed. So what is the R?
120.
Yeah, this one is too simple. Basically, give you something. And R can change from 120 to 140. So I can write R as 120 plus delta R. So from here, you will see delta R. So when this one is 120, delta R should be 0. When this one is 140, delta R should be 20, right? So the range of delta R should be from 0 to 20. And they ask you to determine the voltage across A and B. So you look at this circuit, you will see your VA actually is 5 volt, because here the total here is 10 volt. We have 120, 120, so VA should be 5 volt, right? And your VB should be, this is R, right? This is R over, this is a voltage divider rule, right? R plus 120 times 10. Cost, this one is volt. Right? So to find VAB, so let me do this on the question similar. VAB is just VA minus VB, right? So what you have is 5 minus R over R plus 120 times 10. So this one you have like 10R. So 10 times R here is 10R. So again, 5, you can think of 5 as 5 divided by 1, right? So you need to multiply R plus 120 to here. So this one you have 5 times R plus 120 minus 10R over R plus 120. So what you have is 5 times 120 is 600. So you look here, you will see you have 5R plus 600 minus 10R. So this one should be 600 minus 5R, right? 600 minus 5R over R plus 120. So that is B. Right? 20. Yes. Oh, they want to have the in terms of delta R. So you see 600 minus 5R, but your R, right? 5R. Your R is 120 plus delta R, right? Correct. Your R is 120 plus delta R. So this one is 600 minus 600 minus 5 delta R. So this one should be minus 5 delta R. Right? As I explained here for you. Because your R is 120 plus.
Shouldn't the delta R be R minus 120? Oh,
But here I have R. Here I have R. They ask me the result in terms of delta R. So I have to replace R. I have to change R to delta R. So the R is given by 120 plus delta R. So I put it here, right? Is that okay or not?
oh yeah, so, okay.
Yeah, so this is minus delta R. For the bottom, you have R and right on top here. It's part of some problem. You have bottom is R plus 120. So your R is 120 plus delta R, then plus 120. So this one should be 240 plus delta. 240 plus delta. Right? Plus, okay. Then they ask this. Determine the range of VAB. Now, this is a formula for VAB. Delta R can be from 0 to 20. So when delta R is 0, your VAB should be 0 because it multiplies with 0 here. But when your delta R is 20 ohm, so your VAB is minus 5 times 20 over 240 plus 20. So this one is minus 100 over 260, right? Right. So this one is minus 5 over 13. Yeah. So this is the range of VAB. Okay. Now, so that is a range. Now, the question is like this. You see from the bridge, right? From the bridge, the range you have is 0 volt and can go down to minus 3 over 15, is it? Yeah. No, 5 over 13. Yes, should be 5 over 13. Now I want to have a transformation. I want to have a transformation in such a way my voltage now is from 0 to 5. So I have to find to design this kind of circuit allowing me, and this one is V out. So something like this one V out, and this one is your this is your VAB, right? But to visualize, you can think in this way. And now to form of C. Now once you have K and once you have C, you can design a circuit to implement this transformation. This one is a little bit of mathematics. Why it breaks again? Is that okay now? Is it okay? Is it better now? I don't understand what happened to my Wi-Fi today. Now the formula they want is here. V0 is K times VAB plus C. Right. Right. Okay. So now you'll see, right? What they want is when VAB is minus 5 over 13 volt, then VOut is A minus 5 over 13 plus C, and this one is 0. And when VAB is 0 volt, right? And so what they want, K times 0 plus C should be 5 volt. Now, easily, I call this equation is 1, equation is 2. Easily, you will see from 2, C must be 5. Right? Because K times 0, and if you sub C equal to 5 into 1, so K times minus 5 over 13 plus 5 is 0, and K times minus 5 over 13 is minus 5, and K times 5 over 13 is 5 itself. So K should be 13 times 5 over 5. So this one is 13. Correct? So it should be 13. Now you take a look. Any part you don't understand, you let me know.
So you're trying to map 0 to minus 15 to 0 to 5, right?
Yeah.
Using a straight line equation, right?
Yes. One is a straight line.
Okay, Ken, thank you.
Remember y is C So this one, basically that because our output here is VO, so our Y is VO and our X is VAB. So that is something. Then he designed a circuit implementation. This one. We done all this before. We done all this before. Let me show you. Check the 6. Yeah. It actually is in the topic number 6. Topic number 6. So let me copy the circuit over. Right, so the equation you need to implement is this one should be your V. This should be your VL. The equation in VL is 13 VAB 5. So there's 5 volt, right? You need to have 13 times. Right. So for example, if you want to have 13 times, so what you need to do is this one is R, this one is 13R, right? You can choose, right? I mean, this one should be 13R, this one should be R. So this one allows you to amplify 13 times. And because the 5 here already 5 volts, so this one is also 13R. So this branch, right? This 13R, this 13R, so basically you have 5. And here, of course, this one is a summing amplifier, so we have the minus sum, right? So this portion, the V here is 13 minus 13R over R of VAB minus 13R over 13R of 5. So this one is a minus 13 VAB minus 5. But this portion basically is multiplied with 1 minus 1, right? This one allows you to multiply whatever here with minus 1. Therefore, this portion here, right, should be 13 VAB 5. So And this is just a bit of testing for people to have a higher mark than others. That's whether our is linearly dependent on R. Right? So quite easy to understand because look here, if you look at the formula of VAB, if you look at the formula of VAB in terms of VAB as a function of R, this one is non-linear. This one is non-linear. If you want to have a linear, right? If you want to have a linear, then it must have a straight line. So you look here, you see this one is non-linear. This one is non-linear, and then you amplify using a straight line. So of course, this here, right? It's not a linear function. In other way, you can think of this. Now, here, this is function G. For VAB is 600 minus 5R over R plus 120. Yeah. So V out is 13 times this. So from here, easily you see this one is you constant, right? Doesn't matter. The thing is here. This all in the it's not linearly dependent. Basically, here you cannot have a straight line, right? If linearly dependent, it means you have a straight line. Here you don't have a straight line. Where did you miss me? Okay, so basically what I say was you have a formula for VAB here, right? If you want, you can have a formula for VR, which is 13 times VAB plus 5. So we have this part, it just add a constant. So we look at this part. This part is not a straight line, right? This one is not a straight line. So it cannot be linearly dependent. Linearly dependent is must be have a straight line like this. V out is linearly dependent on VAB. This one is straight line. But because VAB is a function of R, so in the end, V out is not linearly dependent on R. So this one, if you can't do this one, just forget it. Just a few marks. The main point is try to do, and all this we have done in our tutorial, in our lecture, right? And also in other courses we have done up to now. Okay. So please take note of something like this. There must be questions similar to this, and then you can have 5 or 6 marks, and that's very good. Okay. So I think our exam will be on after Chinese New Year, right?
Yes, don't do that.
23rd. Okay, 23rd. Okay, 23rd. So it's on Monday lah. It's on Monday. Okay. Okay. So from now to Monday, if you need help, feel free to contact me. If you need to have like MST meeting, right? Because after this, we have Chinese New Year, so I think everyone wants to have some time to enjoy. So if necessary, then next Saturday or next Sunday, next Saturday or next Friday, if you need to ask me anything and you want to talk, feel free to contact me. I have another MS team, a short MS team meeting for you, just in case further questions. By the way, the reliability part don't need to study, okay?
The exam format. Exam format.
Sorry,
Do you have the exam format for the exam?
the exam.
Exam format, like your MCQ or not? SB2, question or what? Exam format.
Now, look, the format, can you see I have question 1 and question 2? My part has 2 questions. Mr. Chan has 2 questions, and now to have you have MCQs, right? And please practice the 2 quiz in polite mode for the MCQ questions, and then he has another question, sir. Just now, I think he has given you quite a lot of hints already. Okay, let me type here in the chat.
So will you send out this the one that you write just now in the MS Team?
Of course. Right away after
thank
I
you.
end, 1 minute after I end the lesson. Okay, then type something to the meeting chat. Okay, let's send the format in the chat. Okay, so I will send this one now. Okay, so if you have questions, you can ask now, or I think you need time to first. Okay. Okay. Okay, so thank you and enjoy your Chinese New Year holiday.
Thank you, sir.
Okay, I think we can end it now. Everyone.